Hi, high school chemistry teachers. I'm Kendra, creator of ChemEd Solutions, and it's my mission to change the narrative of high school chemistry from yuck to yay by designing student and teacher materials that allow you to focus on what matters most, getting all your students to be confident and successful without the burden of using your personal time to do so. I support you by giving you my best proven tips vetted by thousands of students, parents, and case managers. So today's tip is in the unit of nuclear chemistry, focusing on water temperature changes in nuclear power plants. So nuclear power plants, we know, are powered by water and temperature changes. And we also know that what they are giving off into the atmosphere, the steam that we see from the cooling towers, is not radioactive, which is a common misconception for our students. And students find it helpful when I would take time to draw where the water is heated and hot and when it is cooled and cold, and help them see the three different pipelines of the water, and again highlighting how the water that's steam coming out of our cooling towers is twice removed from those control rods and our radioactive materials. So I draw over the diagram with red for hot water and blue for cold water, and I have my students use marker to see where these changes occur. So this is a diagram. It's the same one that you will see in our chemistry notes teacher toolkit. And again, you can purchase that on my website. And I got it from the U.S. federal government, the United States Tennessee Valley Authority. So it's the most accurate one, and it's pretty simplified for our students to understand. So with this, I start with the area that they're most concerned about. I say, okay, we've got this first loop, and our water starts off cold, and then it gets heated from the chemical reaction that's happening in the reactor. And we've already talked about what's going on in the reactor. And so they know that this gives off heat energy. So we know that then our water absorbs it, comes up, and then passes through in a pipe this water line, and that the heat here is absorbed then from our water up here. And additionally, it goes through this condenser and cools off again. So this is our first one. Then my second line here, I like to start where it picks up the heat. So my cold water picks up the heat here and gets hot. This hot water turns to steam to turn my turbine, and then eventually comes down through a condenser and passes past my cooling water pipe here and comes back as cold, so it again can pick up the water and the heat from the water here. So this is my second loop. And then my third loop, which is now twice removed, I have my water coming in from my reservoir nice and cold. It goes ahead and it cools my steam coming off of my turbine and gets warm, so it picks up the heat here, and that heat comes out as steam out my cooling towers. So again, having them draw it helps them understand that this temperature and the water changes the temperature changes of the water is really what drives it. So then I would ask my students, okay, explain to me, where do the temperature changes happen? What happens in my leftmost pipeline, in my middle pipeline, and then in my right pipeline? And that's the kind of answer that I would expect to have from them, that my left one goes in my reactor from cold to hot, the condenser's hot back to cold, my middle pipeline, my steam generator, from cold to hot, and then condenser's hot to cold, and then my right pipeline, the cool water absorbs the heat from the steam turning the turbine, which is my cold to hot, and then my cooling towers go back from my hot to cold. So to never miss a weekly teacher toolkit tip and get access to a PDF copy of both the teacher and student versions, there's a student version of this as well that I have for you to use. Sign up for my email newsletter at www.chemedsolutions.com/chem-guide. And in addition to weekly teacher toolkit tips, when you sign up, I have a few gifts just for you, including a high school chemistry course outline, a pacing guide so you know how long to spend on each unit, a unit checklist with NGSS standards, and my personal teacher planner to keep yourself organized, less stress, and enjoying life. With all that, thanks for joining in, and happy sciencing!